Ever wish your inbox could answer itself and get smarter every time it makes a mistake? Today, we'll build exactly that. A self-learning email agent that reads your new messages, drafts a reply, asks a human only when it's unsure, and absorbs that feedback so the next email is spot on. Alright, let's check out the demo first. I have these two workflows in n8n that handles the entire logic. The first workflow gets triggered whenever a new message is received. Let's send this test message and see everything in action. I'm sending this email as a client asking for a couple of details on the engagement model, typical timeline from kickoff to first deployment, NDAs and post-deployment support. Let's send it. It is received on the other side. So the workflow executed successfully, and what happened here is that it received the email and then the AI agent created a response and then replied back on the Gmail. And this is the email thread and this is the response sent by the AI agent. And it's looking really good. Currently, AI agent has access to the Supabase vector store where we have created embeddings for our private documents, and that's how it knows all of those details. Now let's ask something that it doesn't know and see how it acts. Let's send another email and ask more in-depth questions that the AI agent wouldn't know about. And let's see how the workflow executes. And the workflow execution is complete. And this time, instead of sending the reply, it took this route where it saved the email details and the response that it drafted in the Google Sheets to get human feedback. So this is our Google Sheet, and as you can see, we have the original email and the draft that it created, and now it's waiting for the human feedback. So let's give it some directions on how to handle it. So I've given some details and directions related to the questions, and after doing this, let's set the status to send. And once this is set to send, our next workflow will execute. And this workflow has executed successfully. It processed the feedback, updated its internal information and the RAG documents, and replied back to the user with the final response. And this is the response we received for our initial email. Now, before getting into the implementation, let's understand what self-learning agents are and how they work. A self-learning agent is just a software that perceives an event, for example, an email, a chat, or a sensor signal, and then it decides what to do using the prompt rules that we have defined and using the large language model. And then it takes actions using the tools that we have defined. It may send a reply or call an API, etc. And finally, it learns from the outcome. So the next time it does the job a little better. Now, there are two ways of improving the performance of an AI agent. One is by improving the prompt, and the other is improving the knowledge base that it has access to. And that's exactly what we have done in our workflows. Now let's go through these workflows one by one. So the first workflow gets triggered when a new message is received. So it starts with a Gmail trigger, and then it fetches a dynamic prompt from the Google Sheet. So in the Google Sheet, we have created one more tab, dynamic var, where we are storing our prompt, which we will dynamically inject into our AI agent. So we fetch that prompt over here. Next, we convert the HTML content inside the email into the markdown so that it removes all the HTML tags and cleans it up. Then in the AI agent, we have provided the subject and the email content. And in the system prompt, we have given its role and how it should act. And then here we are injecting that dynamic prompt that we fetched from the sheet. And then we have defined some output rules where this AI agent will draft the final response for the email, and then it will identify the confidence score from 1 to 5. If the confidence score comes out to be 4 or 5, then it will take this route using this node where it will send the response. However, if the confidence score is less than 4, then it will take this route. So here we are converting that HTML into the markdown so that it's easily readable in the Google Sheet. And then we are adding that row in the sheet. And that's how this row is added with the email ID, original email, the draft that the AI agent has created. And then it waits for the human feedback because the confidence score was less than 4. So it's looking for human feedback on this particular response. In our demo, we added this content giving some details about how many sev2s were received, on-call details, and link to the DPA template link. And once the status is updated to send, the second workflow gets triggered. So this AI agent has access to the Supabase vector store, and that Supabase vector store contains embeddings created out of the company docs. So it already has the knowledge about the access to the company knowledge base. Auto-fixing output parser is just making sure that the response written by the AI agent contains these two fields, final response and resolution score. Now, once the human feedback is added and status is set to send, the second workflow gets triggered. In this workflow, we are first checking if the status is empty or not. If it is not empty, then we will proceed and get the dynamic prompt the way we did in the first workflow. So we will fetch the dynamic var, which is the prompt, from here, and then this information extractor node will process the human feedback and it will try to extract the details out of it to improve its performance or knowledge base and come up with the final response. So we have provided the current dynamic prompt which is already there, then the original received email, and this is bot draft is the initial draft created by the AI agent, and then the human feedback is the one that we added to our sheet. And then we are expecting these three attributes from here: updated prompt, RAG additions, and final response. And this is what we have received. Once that is done, we are using this markdown so that it's properly rendered in the Gmail, and then we are sending the response. Another thing that we are doing is, in the switch case, we are checking if updated prompt and the RAG addition is empty or not. If updated prompt is not empty, it means that some changes are required in the dynamic part of the prompt. And that's where we are saving the updated prompt back to Google Sheet, and it will get updated over here. Once this is updated, the next time our first workflow runs, it will fetch the updated dynamic prompt and inject it in the AI agent. And in parallel, it will also check if the RAG needs to be updated. So in our use case, the RAG was required to be updated with some information. And these were the RAG additions. And it updates the RAG by using the Supabase vector store node, which creates chunks and then their corresponding embeddings and save them in the vector store. Now, once it is done updating the dynamic prompt section and the vector store, the next time the first AI agent triggers, it will use that latest information and its performance should improve. Now, there are a few things to consider while implementing these kind of systems. Since these workflows are directly impacting the prompt which is used by the main AI agent, we need to be really careful and have some mechanism to observe those changes. One way could be that you set the frequency of second workflow once a week, and just before updating the prompt in the sheet, you can use human in the loop node. And once you review it and approve it, then only it will get updated. That way, it gives you more control over what's happening in the AI agent. Instead of Google Sheet, you can also use Airtable or any other service you want. If you want to learn how to build real-world AI systems and automations, don't forget to check out my paid community link in the description. This community will have everything to take you from complete beginner to a really advanced AI systems architect. You can download these workflows from the free Skool community. You can find the link in the description. If you found value in this video, don't forget to like and subscribe the channel for more content like this. Thanks for watching and see you in the next video.